Welcome to our channel. So in today's lecture, I'm going to explain tailing in chromatography, and this is one of the key concepts if you are doing system suitability parameters in chromatography. So what is basically tailing? I will explain four things. Basic concept of tailing. I will cover basic concept of tailing. Then I will explain why tailing occur, why tailing occur, and then I will explain difference between EP and USP tailing, and finally I will explain how to minimize tailing in chromatography. So these are the four main things that I'm going to explain. So basically, what is tailing? If you in chromatography, you will get the response in chromatograms, and the peak would be, I'm explaining general concept. So if you're getting a peak like this, where the one side of the peak is sharp and the other side is inclined like this, so it means that the over chromatogram has a tailing effect in that one. So basically, what does it mean by tailing? So it goes back to the symmetry of the peak, symmetry of the peak. And what does it mean by the symmetry of the peak? So symmetry of the peak, if we get a sharp peak in the both sides, like if we cut the peak from the center, so this part, like this is, if this is 0.5 minutes and the other part is also 0.5 minutes, then we'll say that the peak is symmetric. But if the peak is asymmetric, means any one of the side is greater or lower than the other side, then we'll say that the peak is asymmetry. And asymmetry comes in two forms. Sometimes peak would be like this, from the start peak like this, and then enters at the sharp end. So this is called fronting. This concept is called, and this is very rare. Fronting is very rare, but the tailing, this one is very common. Not very common, but mostly we are using these parameters to for the system suitability parameters in most of the pharmaceutical analysis or quality control analysis. We are checking the tailing. Then why tailing occurs? This is one of the key concepts. So in chromatography, the separation is based on the interaction. Like if this is the column and our analyte is moving in the column. So if our analyte forms some secondary interaction with the stationary phase, so the mobile phase is moving like this. This is our stationary phase, that is column stationary phase, like C18 column we are using in any other column. If our analyte forms some kind of secondary interactions and it holds tightly to those stationary phase, like analyte is moving at the normal speed, but some of the analyte form very strong interaction with the stationary phase, so it elutes very late at the end. So this will give rise to the tailing. So what is the problem with the tailing? If tailing occurs, what does it impact? Like this is the area that we normally get. So this is not the true representation of that area. Like if we are getting area like 18,000 with tailing, maybe if it's a sharp peak, that would be 14,000 or somewhere. So that will impact like how much of our analyte is present in that particular sample. So because of that, it is very important system suitability parameter to check if the peak or the analyte is separated properly. Then there are two things that are being discussed. One is EP. This is European Pharmacopoeia. In that one, the USP tailing is slightly different way of calculation than in USP, that is United States Pharmacopoeia. So I have one picture, I will explain. So in case of the USP, United States Pharmacopoeia, so this is tailing factor. Basically this one at the top image, this is according to USP, United States Pharmacopoeia. So what is this one? This is the peak front, this is the peak tail. So that's the maximum height H, and you see this is in the center. So this part is called A, this part is B. In United States Pharmacopoeia, the tailing is measured at 5% of the peak height. 5% of peak height. Total height of the peak in this case is h, and the 5% is 0.05 h. So at that point, this is the point. At this point, the tailing is calculated. So how do we calculate? This is the formula. So TF, in case here, TF is equal to A plus B divided by 2A. It's a slight different from European Pharmacopoeia. Say, if I will go with the random numbers, like this one, A is 0.2, 2 minutes, and it's always in the minutes, plus if B is 0.4 minute divided by, this is 2 into 0.2, so that tailing would be equals to 1.5. So this is there are some there are different limits for the tailing. For sometimes the limit would be 0.8 to 1.2, and sometimes we have a limit till 5 till 2. So it all depends upon the particular specific product that we're testing in the peak area. Like if it's a big area is coming, then the tailing would be slightly different. So these are the basic parameters, like how you calculate the tailing. Then this is asymmetry factor. This is according to European Pharmacopoeia, EP. It's in the British Pharmacopoeia as well. So what does it mean in this one? This is calculated. The main difference between USP and EP is in EP it is calculated at 10% of the peak height. Here I mentioned this is USP is 5% of the peak height, and in EP this is 10% of peak height. Peak height. So what does it mean by 10%? See, this is the total height h, and 10% is 0.1 h. So here I have 0.05 h, here I have 0.1 h. So in this case, if we are calculating tailing, so AS, or we can say tailing factor, simple, in EP, that would be B over A. In the same example, like I have given 0.2 and 0.4, so B would be 0.4, A would be 0.2, so tailing would be equal to 2. So the same factor, same peak, if we are calculating in USP, gives the tailing of 1.5, and in EP, it's giving the value of 2. Why? Because this is calculated at 10% of the peak height. 10% of the peak height means this is, if you go from the bottom, this is the baseline, that's the total. If this is 100 units, then we are calculating at 10 units. While in case of USP, we are calculating at 5 units. So these are the ways to calculate tailing in USP and EP. And the other thing that I mentioned, how we can minimize tailing. Tailing has a very huge impact in calculation because you didn't get the representative area, so it gives a lot of problem. So that can be minimized by, if you overload the column, then that's a problem. So to minimize tailing, sometimes, first of all, if there are too much sample, we need to reduce sample overloading. Like if too much samples are overloaded, then that gives tailing. Then sometimes we need to optimize pH of the mobile